Welcome back everybody. In the previous video we built a fully working local AI assistant with conversation memory, model downloads, speech output and a modern interface.
Hello again. It's lovely to chat with you.
Today we're going one huge step further. Instead of chatting with text only, our application will now understand images. We'll be able to upload a picture, send it together with our prompt and let Ollama Vision models analyze everything locally. By the end of this video you'll have a complete ChatGPT-style vision assistant running entirely on your own computer. Let's start by extending our data model. Every message currently stores the role, the content, the timestamp and the model name. That works perfectly for text conversations. But images introduce another piece of information. We also need to remember which picture belongs to which user message. For that reason we're adding a new property called image path. This simply stores the file name of the selected image. Nothing complicated. It's just one additional string. The nice thing is that our existing save and load logic already serializes the chat message object. That means images will automatically become part of every saved conversation without rewriting our storage system. Sometimes adding one small property enables an entire new feature. Next we're adding a few new member variables to form one. The first one is our image button. This becomes the entry point for selecting files. Next comes selected image. This variable simply remembers which image the user selected before pressing send. We're also adding pending image bubble. This will temporarily display the selected picture inside the conversation before the AI has answered. Finally, we create a context menu strip. Right now it only contains images. But this design is future-proof. Later we can add PDFs, Excel files, audio recordings or even drag and drop support without changing our interface again. This is one of those small architecture decisions that pays off later. Before users can analyze images we have to offer vision-capable models. Instead of only listing language models like Llama or Mistral, we're replacing the list with models that actually understand pictures. Models like Gemma 3, Java, minicpm-v. The initialization code doesn't need to change. It already checks which models are installed locally. The only thing we're changing is the available list. Everything else continues working exactly like before. I'm also increasing the HTTP timeout to 10 minutes. Vision requests usually take longer than normal text requests because the image has to be encoded and processed by the AI model. Depending on your hardware and the selected vision model, this can take some time. Increasing the timeout helps prevent unnecessary timeout errors during image analysis. Alright, now let's update our user interface to support image uploads. Most of the build UI method actually stays exactly the same. The sidebar, the chat area and all of our existing controls continue to work just like before. After a small change of the height from input panel we first change is at the bottom of the window. Instead of placing our rich text box directly inside the input panel, we're introducing a new panel called input bar. This panel becomes a container for everything related to the message input. It gives us much more flexibility because we can now place multiple controls next to each other, just like ChatGPT does. Next we're creating our new image button. This is the small plus button on the left side of the input area. I chose a larger Sego UI symbol font so the button is easy to recognize, remove the border for a cleaner appearance and use the same dark colors as the rest of the interface so everything matches our theme. Now, clicking this button shouldn't immediately open a file dialog. Instead, we're creating a context menu strip. At the moment it only contains a single menu item called Image, but this is a much better design because in future videos we can easily add support for PDFs, Word documents, Excel files, audio recordings or any other attachment without redesigning the interface. After creating the menu we connect it to our Image button. Whenever the user clicks the button, we simply display the context menu strip directly beside it. This creates a much more modern user experience and keeps our interface ready for future features. The next change is on the right side of the input area. Since we've added a new button on the left, we need a little more room on the right. For that reason we're increasing the width of the right panel from 160 pixels to 200 pixels. We're also making the combo box wider so longer model names like minicpm-v or Qwen 2.5 VL fit much better without being cut off. Because the combo box is now wider, we also resize both the send button and the voice button. Instead of using the full width of the panel, each button now uses half of the available space. This creates a cleaner layout and gives the interface a much more balanced appearance. The final change is how we assemble the controls. Previously the rich text box and the right panel were placed inside a wrapper panel. Now everything is added to our new input bar instead. First we add the rich text box. Next we add the image button. Finally we add the right panel containing the model selector, the send button and the voice button. The result is a much more flexible layout that looks closer to ChatGPT and gives us plenty of room to continue expanding our AI assistant in future videos. Now let's clean up a bit to keep the structure. Now comes a very important improvement. Not every Ollama model understands images. If someone selects Mistral and uploads a picture, nothing useful would happen. So before opening the file dialog we verify whether the currently selected model supports Vision. Our helper method simply checks the model name. If it's Gemma 3, Java, minicpm, we continue. Otherwise we display a friendly message explaining which models support image analysis. This prevents confusing errors before they ever happen. Now let's implement the code that allows the user to select an image. The first thing we do is verify that the currently selected model actually supports Vision. Not every Ollama model can analyze images. Models like Mistral or Llama are excellent for text, but they won't understand pictures. That's why we call our Vision model method first. If the selected model doesn't support image analysis, we simply display a friendly message explaining which Vision models the user should select instead. This prevents confusing errors and gives the user immediate feedback before they even choose an image. If the selected model is compatible, we continue by creating a standard open file dialog. Next, we limit the file selection to common image formats like PNG, JPEG, BMP, GIF and WebP. This makes sure the user can only select files our application is able to process. After the user has chosen an image, we perform one more quick check. If they cancel the dialog instead of selecting a file, we simply return from the method and nothing else happens. Otherwise, we store the full file name inside our selected image variable. This doesn't upload the image yet. It simply remembers which file the user wants to send later when they press the send button. Next, we immediately create a new chat bubble containing the selected image. This gives the application the same behavior users already know from ChatGPT. The image appears instantly inside the conversation, even before the AI starts generating a response. Finally, we change the background color of the image button to Dodger blue. This small visual indicator lets the user know that an image has been attached and is ready to be sent together with the next prompt. Simple details like this make your application feel much more polished and provide clear visual feedback throughout the user experience. Now it's time to upgrade one of the most important methods in our application, the add bubble method. In the previous version, our chat bubbles could only display text. That worked perfectly for a text-based AI assistant, but now we also want to support images. The first change is in the method signature itself. We're adding a new optional parameter called image file. This parameter will contain the path to an image whenever the user uploads one. Since it's optional, all of our existing text messages continue working exactly as before without changing any other code. Inside the bubble, we introduce a new variable called y. This variable keeps track of the current vertical position where the next control should be placed. If no image exists, the text starts right at the top of the bubble. If an image is added, the text will automatically move underneath it. Now we check whether an image was supplied. First, we verify that the image path isn't empty and that the file actually exists. If both conditions are true, we create a new picture box. We load the selected image directly from disk, set the size mode to zoom so every picture keeps its aspect ratio, and define a fixed width and height to keep every image looking consistent inside the conversation. After adding the picture box to our bubble, we simply move our vertical position below the image. This means the next control we create will automatically appear underneath it. Next, instead of using the panel's text property, we create a separate label for the message itself. This gives us complete control over the text layout while allowing the image and the text to exist together inside the same bubble. We position the label using our current y coordinate. If no image exists, the text starts at the top. If an image was added, the text automatically appears underneath it. Finally, we calculate the size of the bubble. Its height is based on the bottom of the text label, and we also make sure the bubble has a reasonable minimum width so even very short messages still look clean and balanced. Everything else in the method remains exactly the same. We still position user messages on the right, AI messages on the left, add the bubble to our messages panel, automatically scroll to the newest message, and finally return the completed chat bubble. With just a few changes, we've transformed a simple text bubble into a much more flexible container that can now display both images and text, giving our local AI assistant a much more professional ChatGPT-style experience. We also need to update our update bubble method. Just like before, we begin by checking invoke required. Remember, Ollama streams its response on a background thread, so we always have to make sure that any user interface updates happen on the main UI thread. If invoke required returns true, we use invoke exactly like before. The only difference is what happens inside the invoke block. Instead of writing directly to the bubble, we now loop through every control inside our panel. As soon as we find a label, we know we've found the control that contains the AI response. We simply update its text p. Now let's update one of the most important methods in our entire application, the send message method. Most of the existing logic stays exactly the same. We still validate the input, create the user's message, generate the AI response, stream the output and save the conversation. But to support Vision, we need to make a few important additions. The very first change happens when we save the user's message. Previously we only stored the message text. Now we're also saving the selected image path inside our chat message object. This means every conversation remembers not only what the user asked, but also which image belonged to that prompt. Since our conversations are already serialized to JSON, this new property will automatically be saved together with the rest of the chat history. The next change happens before we call Ollama. In the previous version, we created the generate request directly inside the generate async method. That worked perfectly for text-only conversations. However, Vision models require one additional property called images. To make our code easier to read, we now create the generate request first and store it inside a variable called request. At this point, the request still contains exactly the same information as before. The selected model, the complete conversation prompt, and streaming enabled. Now comes the new Vision functionality. Before sending the request, we simply check whether the user has selected an image. If no image has been selected, nothing changes. The request behaves exactly like it did in part 3. But if an image exists, we read the file from disk and convert it into a base64 string. This step is required because Ollama expects images to be sent in base64 format rather than as normal image files. Once the conversion is complete, we simply assign that base64 string to the images property of our request. That's all it takes. Our request now contains both the user's prompt and the uploaded image. From this point forward, the streaming code remains exactly the same. The only difference is that instead of creating the generate request inline, we're now passing our request object into generate async. Everything else continues to work exactly as before. The AI still streams its response in real time. The chat bubble is updated continuously. Voice output still works. Conversation memory still works. We've simply given the model one additional piece of information to analyze. Finally, after the response is finished, we perform a little cleanup. We clear the pending image bubble reference, reset the selected image path and restore the image button back to its original color. This is important because otherwise the next prompt would accidentally reuse the previous image. With these few changes, our application has evolved from a text-only assistant into a complete vision-enabled AI assistant, while keeping the rest of our existing code almost entirely unchanged. The final step is making sure saved conversations restore their images. Since every chat message now stores an image path, we simply pass that value back into Add Bubble whenever an old conversation is loaded. That's all it takes. At this point, we still have one compiler error left. Can you spot what we missed? Take a close look at the code and see if you can find the problem before we fix it. Pause the video if you need a little more time. If you think you've found it, let me know down in the comments. I'd love to see how many of you caught it before I did. And don't worry if you couldn't find it. That's completely normal when you're making lots of changes to an application like this. Let's fix that final compiler error together and get our vision-enabled AI assistant up and running. Previously our bubble was just a label. A label can only display text, so it's no longer suitable for what we want to achieve. Instead, we're replacing it with a panel. A panel can contain multiple controls, making it the perfect container for both an image and a text message. Simply replace preferred width with width, and the compiler error disappears. Now our bubble is positioned correctly and we're ready to continue with our first test after with the new Vision AI Assistant function. So let's try. That doesn't look quite right. My original idea was to display the context menu directly inside the prompt area, just like ChatGPT. Fortunately, the fix is very simple. If you look closely at the code, you'll notice that because of a tiny typo we're actually calling a different overload of the show method than the one we intended to use. That means Windows interprets our parameters differently and positions the context menu somewhere else. All we have to do is call the correct overload with the correct parameters. Sometimes that's all it takes. A single character or a slightly different method signature can completely change the behavior of your application. That's why it's always worth taking a closer look at IntelliSense and checking which overload you're actually calling. Now let's make that small correction, run the application one more time, and finally test our vision-enabled AI assistant from start to finish. After all this work, it's time to see everything come together. Alright, let's test our vision-enabled AI assistant. The first thing I'll do is click the image button and select our test image. As you can see, the application immediately tells me that the currently selected model doesn't support image analysis. That's exactly why we added this validation earlier in the video. Instead of sending a request that would fail, the application gives us a friendly message and tells us which vision models we should use instead. Since I already downloaded minicpm-v before recording this video, I'll simply switch over to that model. Now let's start with a completely fresh conversation. I'll create a new chat, attach the same image again, and ask my first question. Can you describe everything you see in this YouTube Analytics dashboard? Summarize the most important statistics and explain what they tell us about the channel's performance. Let's send that to our local AI. And there we go. The model correctly recognizes the dashboard, reads the statistics, understands the charts and gives us a detailed summary of everything it can see. Now let's make things a little more interesting. Without uploading the image again, I'll ask a follow-up question. Because our application now has conversation memory, the model already knows which image we're talking about. So my second prompt is: analyze this dashboard like a YouTube growth expert. Identify the strongest metrics, point out any areas that could be improved, and suggest 3 actionable recommendations to help the channel grow faster. Let's send it one more time. As you can see, the model doesn't just describe the image anymore. It actually understands the context, analyzes the data, and provides meaningful recommendations based on what it sees. And that's exactly what we wanted to build. A completely local AI assistant that can chat, remember previous conversations, and now even analyze images using Ollama Vision models. I think that's a pretty good place to end part 4. In the next video we'll continue improving our assistant even further and add even more powerful features to make it feel closer to the real ChatGPT experience. If you enjoyed this video, don't forget to leave a like, subscribe to the channel if you haven't already, and let me know down in the comments what feature you'd like to see next. As always, thank you so much for watching, and I'll see you in part 5. Happy coding, everyone.